The two Mars orbiters had the closest view of Comet 3I/Atlas of all European Space Agency spacecraft during its recent passage near the Red Planet. On October 3rd, when the interstellar interloper made its closest approach to Mars, it was approximately 30 million kilometers away from the orbiters, a distance that, while vast on human scales, provided the closest vantage point any ESA spacecraft could achieve to observe this rare visitor from beyond our solar system. Both orbiters utilized their respective cameras to monitor the comet as it passed, each instrument specifically designed to photograph Mars's surface, which is typically only a few hundred to a few thousand kilometers beneath them. Given that the comet was a relatively dim and distant object, scientists approached the observation with cautious anticipation, uncertain about how much detail the instruments could capture from such an extraordinary distance. ExoMars Trace Gas Orbiter (TGO), equipped with its color and stereo surface imaging system, known as CASIS, captured a remarkable series of images showing the comet as a small, slightly fuzzy white, moving downwards near the center of the frame. This tiny dot represented the core of the comet, including its icy rocky nucleus surrounded by a halo of gas and dust known as the coma. While the TGO's CASIS camera was unable to resolve the nucleus itself due to the enormous distance, an object only a kilometer across would be impossible to detect, comparable to trying to see a mobile phone on the moon from Earth. The broader coma was clearly visible. This halo, stretching thousands of kilometers across, is formed as the comet approaches the sun's solar heat and radiation cause the ices within the comet to sublimate, releasing gas and dust that forms a diffuse cloud surrounding the solid nucleus. The coma's exact dimensions could not be precisely measured with CASIS because its outer edges rapidly fade into the background noise of the image, where the light becomes indistinguishable from the surrounding space. Typically, the material from the coma is carried away by solar radiation and the solar wind, forming a long, trailing tail that can extend millions of kilometers as the comet continues its journey closer to the sun. In the current images, however, the tail remains invisible due to its faintness relative to the bright inner coma. Scientists anticipate that as 3I/Atlas continues to approach the sun, its tail will grow brighter and potentially become observable in subsequent imaging sessions, providing further insight into the comet's structure and activity. Nick Thomas, the principal investigator for the CASIS camera, highlighted the difficulty of this observation, noting that the comet is approximately 10,000 to 100,000 times fainter than the usual targets the camera observes. This extreme faintness presented a significant challenge for the instrument, which was not specifically designed to track distant interstellar objects. In comparison, Mars Express, the other orbiter, used a maximum exposure time of just 0.5 seconds, which limited its ability to detect such a dim object. In contrast, ExoMars TGO was able to use longer exposures of 5 seconds, improving the visibility of the comet and allowing the camera to capture meaningful images despite the vast distance. Beyond imaging, scientists also attempted to analyze the composition of 3I/Atlas through spectrometry. Both Mars Express and ExoMars TGO are equipped with specialized instruments capable of measuring the spectrum of light emitted or reflected by objects, which can provide clues about their chemical makeup. Mars Express employs the Omega and Spicum spectrometers, while ExoMars TGO carries the Nomad spectrometer. However, because the comet was still relatively faint, it is uncertain whether its coma and any emerging tail were bright enough to allow for detailed spectral analysis. Researchers are continuing to examine the data, combining multiple images from different instruments in hopes of extracting further information about the comet's composition and behavior as it interacts with solar radiation. Colin Wilson, the project scientist overseeing Mars Express and ExoMars, emphasized the excitement of observing such an unexpected event. While the orbiters primarily focus on studying Mars, their ability to respond to unforeseen circumstances, such as a passing interstellar object, adds an entirely new dimension to their scientific contributions. According to Wilson, the ongoing analysis promises to reveal new insights into the nature of 3I/Atlas, helping scientists better understand the behavior of objects originating from outside our solar system. The observations from the Mars orbiters represent just the beginning of a broader campaign to study this comet, with future missions set to expand on what has already been captured. Looking ahead, the Jupiter Icy Moons Explorer JUICE is scheduled to observe 3I/Atlas shortly after the comet's closest approach to the Sun. While JUICE will be farther from the comet than the Mars orbiters were, it will have the advantage of observing 3I/Atlas in a more active state, as solar heating will have increased its outgassing and dust production. However, the data from JUICE's observations will not be available until February 2026, as the mission requires time to downlink and process the information. These upcoming observations are expected to complement those from Mars, providing a more complete picture of how the comet behaves as it travels through the inner solar system. Interstellar objects, such as 3I/Atlas, are particularly valuable to astronomers because they offer a tangible connection to regions of space far beyond our solar system. Unlike comets that originate in the Oort cloud or the Kuiper belt, interstellar visitors bring with them the potential to reveal the chemical and physical characteristics of other star systems. The European Space Agency recognizes the scientific potential of such objects and is preparing for future opportunities through the Comet Interceptor mission, scheduled for launch in 2029. Unlike traditional comet missions, Comet Interceptor will be placed in a parking orbit and remain in a waiting position, ready to travel rapidly to a target when one is discovered. Its ideal target would be a pristine comet from the distant Oort cloud, although an interstellar object like 3I/Atlas would provide an extraordinary opportunity to study material from outside our solar system. Michael Kupers, the Comet Interceptor project scientist, explained that when the mission was selected in 2019, only one interstellar object, 1I/Oumuamua, was known to exist. Since that time, 2 additional interstellar visitors have been discovered, each demonstrating significant diversity in their physical characteristics. The ability to intercept one of these objects would represent a groundbreaking achievement in planetary science, potentially revealing details about the formation and composition of other star systems. While it is improbable that Comet Interceptor will encounter an interstellar object that is close enough for direct study, the mission serves as a critical demonstration of rapid response capabilities. It will pave the way for future missions designed to intercept and examine these mysterious visitors, enhancing humanity's understanding of the universe on a much broader scale. Ultimately, the observations of 3I/Atlas by the Mars orbiters represent a significant achievement for ESA, highlighting the versatility of its spacecraft and the scientific value of unexpected opportunities. Through careful analysis of images, spectra, and future observations from missions like JUICE, scientists hope to learn more about the physical properties, composition, and behavior of this rare interstellar visitor. Each piece of data contributes to a growing understanding of the broader cosmos and humanity's place within it. By studying objects like 3I/Atlas, astronomers not only gain insights into the materials and processes that exist beyond our solar system, but also strengthen our ability to respond to similar discoveries in the future. The efforts to monitor and analyze 3I/Atlas underscore the importance of flexible, multi-purpose space missions capable of adapting to unexpected events. These observations offer a glimpse into the exciting frontier of interstellar exploration, where the unexpected can provide opportunities to expand human knowledge in ways previously thought impossible. As ESA and other space agencies continue to observe and study such objects, each new interstellar visitor serves as a reminder of the vastness of the universe and the exciting scientific discoveries that await. Comets like 3I/Atlas act as ambassadors from distant regions of the galaxy, connecting Earth with the larger cosmos and demonstrating the remarkable potential for exploration and discovery that lies ahead.